Have you ever wondered how pilots control the up and down movement of an aircraft? This intriguing question takes us into the fascinating world of aviation, where we'll unravel the mystery of pitch, one of the three fundamental rotational movements that an airplane can perform. Picture an airplane in your mind. Now imagine a line connecting the nose and tail of the aircraft. This is the pitch axis, a virtual line around which the airplane rotates. Pitch in aviation refers to the up and down rotational movement of an airplane around this axis. It's a bit like a seesaw, with the pivot point being the pitch axis. The pitch movement is essentially what gives an airplane its ability to ascend or descend. When an airplane pitches, its nose moves up or down relative to the horizon. To visualize this, think of a bird soaring high in the sky, then suddenly swooping down towards the earth. That's pitch in action. It's important to note that pitch is just one of three movements that an airplane can perform. The other two are roll, which is the side-to-side movement, and yaw, the left or right movement of the nose. It's the harmonious combination of these three movements that allows an airplane to maneuver in the sky, much like a ballet dancer pirouetting on a stage. But let's not veer off course. For now, we're focusing on pitch, the up and down movement, the one that gives you that thrilling feeling of liftoff during takeoff, or that slight sinking sensation in your stomach when the plane begins its descent. To sum it up, pitch is the rotational movement around an axis that runs from the nose to the tail of an airplane. It's what allows the airplane to move its nose up or down relative to the horizon, giving pilots the ability to control the aircraft's altitude. So, when an airplane pitches, its nose moves up or down relative to the horizon. And now, you know a little more about the fascinating dynamics of flight. Stay tuned as we delve deeper into the world of aviation in our next segment. Now, you might be wondering, what part of the aircraft is responsible for this movement? Well, let's dive in. The primary control surface for pitch is the elevator. And no, we're not talking about the one in your office building. This elevator is a critical component of an airplane's anatomy. The elevator is conveniently located on the horizontal tail surface, also known as the tailplane or stabilizer. If you've ever watched an airplane and noticed flaps moving at the tail end, you've spotted the elevator in action. It's an unassuming part of the plane, but it has a significant role to play. So how does it work? Picture this. You're a pilot cruising through the sky. You need to adjust the pitch of the airplane. To do this, you would manipulate the elevator. By adjusting the elevator, you can increase or decrease the airplane's pitch. It's that simple. Think of the elevator like a seesaw. When one end goes up, the other goes down. In the case of an airplane, when the elevator goes up, the nose of the plane goes down, and vice versa. This seesaw motion is what allows the aircraft to pitch up or down. But what does this mean in practical terms? Let's say you're that pilot again. You're cruising at a steady altitude, but you want to climb higher. To do this, you would pull back on the control yoke. This action raises the elevator and, consequently, the nose of the airplane. As the nose pitches up, the airplane begins to climb. On the flip side, if you wanted to lower your altitude, you would push forward on the control yoke. This action lowers the elevator and, in turn, the nose of the airplane. As the nose pitches down, the airplane begins to descend. So by raising the nose, they increase the altitude, and by lowering the nose, they decrease the altitude. It's all a delicate dance in the sky, choreographed by the pilots and their deft control of the elevator. The result? A smooth and controlled flight. So, how exactly do pilots use pitch during a flight? Well, let's start with takeoff. As the airplane speeds along the runway, the pilot pulls back on the control yoke or stick. This motion deflects the elevator upwards. As a result, the tail of the airplane is pushed down, which raises the nose and pitches the airplane upwards. This allows the airplane to climb and gain altitude. Once the airplane has reached cruising altitude, the pilot adjusts the pitch to maintain level flight. Here, the aim is to keep the nose of the airplane just slightly above the horizon. This delicate balancing act between climb and descent helps maintain a steady altitude. But what about when the airplane needs to climb or descend during flight? That's where pitch comes in again. To climb, the pilot increases the pitch by pulling back on the controls, raising the nose of the airplane. On the other hand, to descend, the pilot decreases the pitch by pushing forward on the controls, lowering the nose. And then there's landing, arguably the most critical part of the flight. As the airplane approaches the runway, the pilot gradually increases the pitch to slow the airplane's descent and ensure a smooth touchdown. Just before landing, the pilot executes a maneuver known as a flare. This involves a slight increase in pitch to further reduce the descent rate and allow the airplane to touch down gently on its main wheels. So, as you can see, pitch is a constant factor throughout a flight. It's not just about takeoff and landing, it's about maintaining control and ensuring a smooth and safe journey from point A to point B. Whether it's a jumbo jet carrying hundreds of passengers or a small private plane, the principles remain the same. The pilot must skillfully adjust the pitch throughout the flight to control the airplane's climb, descent, and level flight. So, pitch is an essential tool for pilots to control the airplane's movement and direction. But why is pitch so important in aviation, you may wonder? Well, let's dive into the details. The value of proper pitch control in aviation cannot be overstated. It plays a critical role in ensuring stable flight and maintaining the desired altitude. Picture this. You're in a plane cruising at a comfortable 35,000 feet. The pilot adjusts the pitch, and the aircraft maintains this altitude with ease, providing you a smooth, bump-free ride. That's pitch control at work. It's not just about comfort, though. The pitch also significantly impacts an airplane's aerodynamic performance. By adjusting the pitch, pilots can control the angle of attack, the angle between the oncoming air or relative wind, and a reference line on the airplane or wing. The angle of attack is directly related to the lift an airplane can produce. Too high or too low, and the aircraft can stall or lose lift, which can have serious consequences. But it's not just about avoiding the extremes. Even subtle changes to the pitch can lead to significant changes in how the aircraft performs. Pilots can use pitch adjustments to balance the need for speed and lift, ensuring the airplane operates at its most efficient. Additionally, pitch control is crucial for stability. An aircraft needs to maintain balance to fly safely, and pitch plays a significant role in this. By adjusting the pitch, pilots can counteract forces that might otherwise destabilize the aircraft, such as turbulence or changes in air pressure. In essence, pitch control is a delicate balancing act that pilots master to ensure safe and efficient flight. It's a fundamental aspect of flight dynamics, working in tandem with roll and yaw to provide full control over the aircraft's movement. So, proper control of pitch is crucial for the airplane's performance, stability, and safety. It's an art and science that pilots master over countless hours of training and experience, and it's one of the many reasons we can sit back, relax, and enjoy the flight. As we've seen, pitch is a fundamental aspect of an airplane's movement. It's this up and down rotation of the aircraft around an axis running between the wings that gives us the ability to control altitude and maintain stable flight. Think of it as the airplane nodding its head, with the nose moving up or down relative to the horizon. It's a simple concept, but plays an integral role in the art of aviation. The star player in this movement is the elevator, that nifty little control surface located on the horizontal tail surface. By adjusting the elevator, pilots can deftly increase or decrease the airplane's pitch, raising or lowering the nose to alter the altitude. Like a maestro conducting an orchestra, the pilot uses the elevator to guide the airplane's dance in the sky. And how do pilots use pitch? Well, during takeoff and landing, they adjust it to achieve the desired flight path. It's a bit like a delicate balancing act, making sure the nose is just right to ensure a smooth ascent or descent. And once in flight, they can use pitch to control the airplane's climb, descent, and level flight. But why is pitch so important? Proper pitch control ensures stable flight and allows pilots to maintain the desired altitude. It also affects the airplane's aerodynamic performance and stability. In other words, without the right pitch, we might as well kiss smooth and safe flights goodbye. It's crucial to remember that pitch is just one aspect of an airplane's dynamic behavior. The other two axes of movement are roll, the side-to-side movement, and yaw, the nose left or right. These three axes, roll, pitch, and yaw, work together in harmony to allow pilots to maneuver and maintain control during flight. Remember, understanding pitch is just one step towards understanding the complex dynamics of flight. So keep exploring and happy flying.